the Managing Quality 4.0 costs presented by Dan Zrymiak. The organizers today are Ellen Ermer and Manny Veloso. We'll be taking your questions and just trying to make sure that the webinar runs as smoothly as possible, as smoothly as we can do. Next month, on January 13th, we're going to have Predictive Quality with Industrial Artificial Intelligence for Zero Defects Manufacturing. It's presented by Mo Abwali. And if you take a look in the GoToWebinar control panel, if you take a look down towards the bottom, you'll see handouts, 1 of 5. That one handout is a PDF with a registration link so that you can register for next month's webinar if you would like now. We're going to talk a little bit about RUs, right? They're certainly important to everyone. So you can expect to get an RU certificate within 24 hours of the broadcast ending. We're also going to be putting up the YouTube recording by Friday of this week, and we'll be sending out a link, certainly on LinkedIn, if also my ASQ. So if you do have a question, feel free to ask a question. You can go to in the webinar control panel, open up the question section, and then put one in there. And Ellen and I, our main function today really is to help manage questions and feed them to Dan at the end. Here's a little bit of introduction about Dan. He's got an awful lot of accomplishments on his CV. So I'm not going to read this off to you, but he is an engagement manager based in British Columbia. He's got the typical degrees, but more importantly, I think he's an ASQ fellow and has been awarded several medals by ASQ. He's a big deal, and we're very happy to have him here today. As you can see in the third bullet point, he has a number of different certifications, and also Dan is an author. Dan, thank you for being with us today. We certainly do appreciate it. Before you get started, I'm going to open up with a couple of polls, and people who have been around for a few months should be used to this by now. Basically, we just want to know where you're coming from and why you're here. So here is our first poll. As you can see, the question is, why are you attending today's webinar? And really what we'd like to know is, if you know nothing about the topic, or if you know something about the topic, perhaps you're supporting one of the presenters, maybe you're here for the RUs, and that's fine, we all need them. Another factor is maybe you're just tired of watching YouTube at lunch. So in this case, you get some live entertainment here. So I'm gonna let that run. We're about 30 seconds into it now. I'm gonna give you guys a little bit more, see if we can get up to that critical 80% or so, and then I will show you the results. So let's see here. Okay, you guys are voting. Thank you, I appreciate this. So what I'm gonna do, we're coming up on close to a minute now. I don't wanna take too much of Dan's time. I'm gonna close this and then share the results with you. And you should be able to see that more than half know something about the topic. Certainly a substantial proportion, more than a third know nothing about the topic and they're here to learn more. And then for almost 15% of people, hey, it's a free event and it's kind of cool. So that's all good. Dan, what I'm going to do now is make you the presenter and allow you to share your screen, and we will go from there. Okay, you should be good. I'll let you know if I don't see the screen the way I expect it to. All right, Dan, take it away.
Thank you. Good morning, good afternoon. I'm just want to confirm, first of all, can you see the full presentation, the full page?
Yes, we can, Dan. It looks good.
Okay, it's my pleasure to address the Lean Enterprise Division and those who have come into this. I noticed that 26% are very much along with me that want to accumulate those recertification units. And my advice is, as listening to that, that'll give you a portion. But if you were to actually do a review of this and submit it to your own section or division newsletters as an article, then you get you know, half a recertification unit, and even presenting it gets you more. So I hope that what I can do can stimulate your own creativity in this and help you with your professional development. So for what we're going to do today is really look at cost of quality, which is a very established set of practices. It's relevant to lean in terms of not just identifying value and waste, but also how to target things which could offset value, whether it's management of defects or the handling of risks that are realized. There is an existing approach that's done for software, and I'll summarize that. And because with Quality 4.0, it leverages a lot of what's already being done with information and technology. So I'll briefly touch on some of the Industry 4.0 demands and show how that relates back to what's already been done for software for the last several years and proven effective. There are some ISO standards that specifically address quality characteristics for software and data models, which are found through Quality 4.0 solutions, and I will elaborate on that. So the cost of quality will be more granular when we're determining what does quality really mean for information and technology solutions. And finally, I'll try to bring it all together to not just manage the quality costs, but do it in a way that's systematic and optimizes the returns on investment so that when Quality 4.0 initiatives and innovations are approached, there's a better chance of realizing return on investment and not having the time and effort and resources sidetracked to resolve the unintended consequences. So with that, what I hope is that the cost of quality methods that have been shown to work for software can also be applied to Quality 4.0 solutions. And again, not reinventing the wheel, but taking proven practices that have already been shown to work and applying them to new innovations. And because it's technology based, I use the term intangible, and I'll elaborate on this more in the presentation, but it's Quality 4.0 are not just the products themselves, they also represent solutions that would perform a service or in many cases replicate what used to be done through manual or personal efforts. So it's an upgrade of sorts, but we have to also make sure that we're getting the same benchmark level of services that we were previously accustomed to. And finally, by tracking the failure costs, mitigating those losses. Not every failure can be prevented. So in the event that losses are anticipated, what are the contingencies and mitigations that can be done to offset those? And that's where, I've got some of I'll elaborate on that as well. So this is with the hypothesis that the return on investment of any initiative, but particularly Quality 4.0, can be increased by reducing the cost of quality, which in turn biases that higher focus on preventive and appraisal categories and actions will bring down the failures, not only making the costs lower, but also more predictable. So in software, same categories that we're accustomed to. And again, in addition to managing the costs, there's also the recognition that because software and information technology are less tangible, they are not finite. And the nature of these products is that unlike something physical like a table or a chair or a door or a window, you cannot inspect the quality in. At that point, it's far too late. So the emphasis has to be made at the development and the design and validation stages before you have the constructed solution. In the case of software, it would be before it's put into a production environment. So that emphasis of those earlier phases also modifies the focus of where to devote the effort and attention. Software performs a service. So in addition to the intrinsic technical solution, software, because it performs a service, the determination of whether it is of good or bad quality is also measured on the service metrics. And I've given some examples reliability, responsiveness, usability. But adding to that, there's also an acknowledgement that because something is automated or maybe accessible, the timing and the tolerance is actually much lower for automated solutions than for manual. Consider a transaction. If you travel to a store, purchase something at a brick and mortar store, wait in line at the cashier, having a 5-minute wait time is very much tolerated. However, if you're trying to do the same transaction online, pressing purchase and then waiting 5 full minutes before that purchase is accepted by the system, that would seem like an infinite amount of time. So it's about expectations, and as information and technology advance, the expectations are also advanced. Return on investment. So the cost of quality from the model, and this is drawing from studies done not just by Duran and Deming and Feigenbaum, but also Taguchi loss model, higher allocations toward planning and specific prevention and appraisal of the product at key stages has a measured effect on the reduction of internal and external failures, which has a comprehensive reduction in the cost of quality. So this is true whether this is measured on tangible products or intangible engineering solutions. By emphasizing prevention and appraisal, the stability and predictability will be increased. And examples in software that some other, say, fashionable trends or modes, ethics like fail fast, where you just push out a prototype and wait for the user feedback. What you're really doing in that case is relying on the customers to report. So you're effectively outsourcing your quality back to a customer base who does not report to you, and then because it's unstructured, whether you're using a crowdsourcing or some other rapid communication, then the defects come back to you not necessarily by priority, but just through usage and discovery. And what the risk of that happening is the first defects will be on the user interface, and it'll take longer to get to the root cause. Alternatively, if the prevention and appraisal are done internally by those with the most knowledge of the product or solution being developed, then the defect prioritization can be more commensurate with the importance and critical impact of the product, and efforts to diagnose and resolve can be more targeted and ultimately more effectively applied. So again, to emphasize that targeted prevention and appraisal will have a better effect on reducing failures and bringing down the overall cost of quality. External failures are particularly significant if the overall solution using that software, if the failures from that are particularly profound. And this is some examples of criticality. How severe is the error? A security breach, it might be a minor oversight in terms of the software, but if that oversight causes privacy data to be improperly exposed, a data breach, and permitting things like identity theft, that is an extremely important issue. And then the impact is how many people would be affected, the breadth as well, the range of users, how many are affected, but the impact interruption. If the interruption is during a low usage period, say on a Sunday night of a long weekend, it doesn't affect as many people as if it were to be on prime time, or for example, in advance of a major deadline. If those of you who pay taxes, if the deadline to submit your taxes, the system to accept those submissions went down 48 hours before the due date, that would affect your ability to complete it in a timely manner. So these external failures extend beyond the technical resolution, and for a number of reasons, not just the market confidence in the software itself, but also in those devices that manage the software. A good example is there's a prominent aircraft carrier who, as a result of some repeated software issues, basically had to ground their planes until this particular design flaw was resolved, so that the confidence of the customers using those particular aircraft models was affected. And because if there's transportation is a highly regulated industry, so such maladies would come with regulatory penalties, even as extensive as imprisonment of the key decision makers. So it's very important as a deterrent that if anything that can be done to prevent the external failures, the more extensively the damages, then the more should be committed towards the identification and ultimately prevention of such failures. The internal failures, again, comparing software to finite good, there's only so many ways that a table or a chair or a door or window can fail. And really it's about dimensions, strength, proportion. You can identify very clearly what where something can go wrong. The more complex it is, the more with software, that also increases the scope and scale of ways that failure can occur. Even if the software as designed, let's say something that's designed in the year 2015 is suitable for its environment and its user base, that software will not stay constantly compliant. Unlike a chair or a table, which truly doesn't decline unless it's specifically through wear and tear, software can be affected by baselines and versions of associated systems. How many operating systems and devices have changed in the last 5 years? If there's concurrent or interdependent components, changes to those which interact with the software can also cause that software to lose functionality and capability. Infrastructure as well as the changes in devices. How many of our devices have changed in the last 5 years? And then finally, externally directed revisions. If being based in Canada, we have, for example, the anti-spam. This has caused increased scrutiny on how data is managed and doesn't get released. So any sort of government regulation, whether it's privacy, control of electronic signatures or record keeping, these have to be monitored because that defines whether your solution is successful or failure. And the technical and business impacts. It's not enough just to have a failure. How significant is this? And then the business impact, translating technical malady to how a business operates, whether it's related to its sales, its customers, its supply chain. Does it induce growth? Does it help its employees serve customers and support each other more effectively? And if not, what are the appropriate corrective actions? So to summarize, the breadth and opportunity for failure increases. That in turn increases the types of response that have to be made, not just to identify them, but to ultimately prevent them. So appraisal, we're all familiar with plan, do, check, act, and people are accustomed to a cycle of doing something first and then appraising or inspecting after it's completed. However, software currently is increasingly moving towards different methodologies, Agile framework most prominently, in which these steps are done concurrently or even inverted in one approach called test-driven development. The test cases are actually written as requirements and the software is developed sufficiently to do the testing. However appraisal is done, this must be managed in a way that properly identifies and demonstrates the suitability of the solution in its intended environment. The supporting infrastructure also has to be considered. There are some tests which you cannot manually replicate what's been done, so you have to do it programmatically. A good example is a performance test to simulate a high quantity of users. There is an effort and there are resources specifically for that creation. I've termed that as automation development, generation of test data. This is an activity on its own, which does require an investment, but that investment has to be made in the context of the errors of the potential errors that is preventing. And in terms of development, a term called technical debt is frequently referenced as the value if there's inadequate verification in the solution, then eventually those quality problems will have to be resolved later on. They're inescapable. So strategically is how much of the technical debt do you want to resolve prior to product release? And under the cost of quality model, you'd truly want to eradicate the majority of this technical debt while your solution is within your control before it gets released to the public. And coming back to prevention, I'll elaborate on this later on in the presentation, but specifically, what are we preventing? Understanding what quality is helps us to understand what we have to secure and assure. Software solutions can break this down into two categories: function, the functional related, so the use of the product, and that's what it does. Does using the solution pass or fail? And that's where reliability fits in. The usability, and this is an increasingly important issue when most people want to be able to use the software without having prior training. It should just be almost intuitive to how they would normally complete a transaction or a set of activities. And portability is taking something that you use it on your laptop, you want to be able to use it on your mobile device or on your iPad. So can you get the same outcomes, the same look and feel? And even between devices, can you shift from different versions of mobile devices, for example, and get the same effect? There's also more of the programming issues, how quickly, so efficiently, how quickly does it run, or in turn, if the product is so complex that it pauses while it's trying to complete its processing, then that could be a failure point. Maintainability, can you use different versions and get the same result? As a design changes, those changes have to be applied in a way that does not destabilize the overall solution. And of course, security, protecting your own identity, protecting the information, and that's information and technology are of such importance that it's often it goes to the highest levels of the organization to have traceability, both of these design and information changes. So as you have more ways for a solution to fail, you have a broader scope of items that have to be prevented. And that in turn, if prevention is applied, there will be positive returns on investment along with their planned deployment, so then it increases predictability and assurance. Also, if you consider that each software item is part of a larger composite, the overall system is made more reliable when the individual components themselves are more reliable. So then how does this apply to Industry 4.0 and ultimately Quality 4.0? I started with the software because a lot of these Industry 4.0 capabilities are drawing very much from software and information technology. And this is not a exhaustive list. Additive manufacturing, this is moving from a 2D to 3D visual model in terms of design, and then ultimately taking those designs that are on the computer and having them automatically, having the information automatically migrated to production machines for making that part without having to manually pull and then reset the, so that is an example where having the design in manufacturing can take information from engineering directly to production. But with those advantages also come more opportunities for inaccuracies, especially if the margin of error in some parts can be very fine indeed. Mobile computing, as our workforce we're already remote, and often we have to be on site, and we have at the same time with our smartphone or portable devices already existing capacity for tracking information. How do we make sure that we're able to use those effectively, and then in turn what's captured and collected is properly incorporated back into the system? So in terms logistically, mobile computing solutions appear to resolve many issues. In practicality, it also introduces an additional set of potential quality failures that have to be mitigated and controlled. Digital manufacturing, in this case, enterprise resource planning. This is taking items from functional areas that, capturing the information and then automatically triggering progressive, successive steps from, for example, a customer demand for production that triggers automatically the supply chain to order the inventory. The inventory is brought in and delivered at the time when it goes into the various phases of the manufacturing in terms of timely delivery. That can all be tracked in a single, and as the information is updated, it's ultimately updated to a system that's accessible to everyone who needs that without having to enter data redundantly and reducing the opportunity of missed or incorrect data. This is also, digital manufacturing is an information management solution that should ideally reduce inventory, reduce time to market, and actually enhance how a customer's response or demand can be addressed with value-added services. So, and also in a way that appeases not just the supply chain, the manufacturing, but also if there's additional invoicing or regulatory compliance that has to be brought in, it can all be targeted more specifically. Items like cloud computing and blockchain is really the application, the enhancement of infrastructure and data trackings to use current technology and capabilities. So with these and other augmentations, there are phases of design, development, configuration, and deployment, which I'll elaborate as ways to bring these in, but also that include their own countermeasures of potential failure modes. So within each of these phases, which, so to simplify, I've broken it down into 5 phases, and that's drawing from the ITIL practices, the IT infrastructure library. And I'll elaborate on these, but any solution would have to be analyzed. Is this the right solution? Does it match the business case? Does it match what the company wants to do? But also, is it within the budget? So is there a plan for return on investment and payback? Is there a reasonable expectation? And that's where coming into other issues like scope, resources, schedule, and expectations. Once those are captured and there's consensus and agreement across the necessary stakeholders, there's got to be a qualification stage, both internal and external, for not just the technical solutions, but the partnerships and the arrangements with those partnerships. The best technical solution from the best provider comes up short if that provider is not willing to offer timely support. In contrast, something that is very good commercial solution but is off the shelf and not customizable may be missing key features or may give an imbalanced solution. So qualifying ensures that you have a suitable arrangement of technical solutions and support that map back to what your ideal intended solution is. And getting from qualification, very seldom would you get something off the shelf that immediately works. There has to be some customization and confirmation that the solution is suitable, particularly if it represents a change to something that's maybe currently stable, but needs an upgrade to get to the next level of productivity or financial return. So there is a level of at least meeting the current service indicators. And then beyond that, does it do as it's supposed to do? Does it leave any existing gaps? And especially in a cost of quality model, appraisal is extremely important. So having the verification validation steps would cover that. Deploying and migrating an innovation, whether it's a software application or adoption of a major enterprise-wide system, that has to go through a structured process of timing, communication, and then once it is in place, making sure that everyone in the company or the organization uses it properly and updates the information accordingly. And that's where that change and release phase are. And then as with anything, nothing ever works perfectly on day one. There's always going to be hopefully an initial but declining list of outstanding issues that need resolution. So stabilization is getting it to a point where the critical issues are resolved, and then maintenance, companies don't stand still as they take on new products, new service models, new solutions, perhaps expansion or geographic deployment in other markets. Those maintenance phases have to reflect the current scope of the organization. So with that, the analysis phase, it's very much, if a project management mode is taken, then determining the business need, the budget resources, and the opportunities, that sets up what success looks like, what's the definition of done. And it's very important that the stakeholders who are involved in quality 4.0 and the innovation are brought in at the earliest stages so they can get their consensus, but also their acceptance criteria. So any shortcomings in this phase will be propagated throughout the deployment and be sources of failure. So it's, and it also, in terms of this expectations, it doesn't have to be the best in class, or this is an opportunity to downscale what you can deliver so that you can meet that and declare a win. So it's better to have something that you can confirm a positive outcome and confident delivery than to promise the sky and the moon, and then that becomes a never-ending solution. So the analysis is really about scope, setting scope and expectations. The qualification is important, and it incorporates both prevention and appraisal. If you are dealing with a proven performer, a proven solution, in doing so and making that selection, you are preventing a series of problems, and that's where it's very important to have good qualification, highly detailed RFPs that if the partner falls short, that you've got something that's tangible to guide the relationship. And then in terms of the appraisal, what's the weighting of what your selection criteria are? How important is it to get a good vendor? How important is it to get something customizable? And then I would include the pilot deployment, looking at the initial solutions. Is this really the best interest? Is this something that people in the organization will support? And it's by having this early buy-in that sets things up for more broad acceptance. Alternatively, if the pilot reveals risks, then at least those risks can be contained. And for example, that you're not putting the whole enterprise or the whole product portfolio at risk from a bad pilot. So this is an extremely important issue that not only provides a reference base for ongoing deployment, but also if something is not a good fit, it's an early indicator that you can make a quick correction. The development, and this is also drawing a lot from software because it is the management of software and information technology, looking at the different approaches to, they're called methodologies. So how do you complete the design into a tangible deliverable, or in the case of Agile framework, an incremental deliverable? And doing these through preventive and appraisal, if you're following Scrum, this is done repeatedly in 2 to 4 week increments, so that the solution is always incorporating, what the plans are, but also there's a demonstration that it's verified. And again, test-driven development, that the tests are actually written prior to developing the solution. The test automation itself, as you're dealing with information and technology, automated tests will need to be repeatedly performed as the solution evolves. And whether it's, so in the case of enterprise resource planning, an example could be running simulated customer requests through the different functional areas to show that the triggers are activated, so that if on Monday you get the customer order, then on Tuesday the design and customization can start. On Wednesday, the purchasing can be made for the material. On Thursday, the manufacturing cells or the manufacturing areas can be prepared. On Friday, the manufacturing can be scheduled. On the following Monday, the delivery, however long it takes to go through each of the different areas. On Monday, the shipping and receiving is notified that incoming finished goods are ready for shipment. And so by having those automations, you can continually demonstrate the suitability of the information transfer. Change and release. Again, this is a very good structured in organizations that frequently do innovative solutions. They do so under change management, where the purpose of the change is communicated to the stakeholders who'd be affected by that change, and then not just whether they'd accept it, but also the timing of having such changes would occur. So for example, if you're changing accounting software, you don't want to do it immediately before your fiscal year end, so that in addition to the other work, it provides an unwelcome distraction. So looking for peak periods and slow periods, and understanding when such a change could occur with minimal disruption to the business. Releases, release and deployment are often used interchangeably. And in the case of technology, this would be a confirmation of user acceptance of the solution and it's suitable for its operating environment. So operational readiness checks that something could be deployed. In the case of additive manufacturing, if you're migrating from a 2D to a 3D engineering solution, this would be to make sure that as you changed from 2D to 3D, the users would know this, and then once 3D solutions were made, that the information from that could be then propagated to other functional areas of the company. So that operational readiness would be confirmed. And then deployment represents the point of change. After that, there's the migration of affected services and processes. So if prior to November 30th, you're using two-dimensional designs, and then as of December 1st, it's now three-dimensional, making sure that everyone involved knew to cease doing things the old way and we're adopting the new way. So that involves training, that involves getting confirmation of the people doing the work that they can follow through, and then coming back to the training, awareness, and competence. Competence is monitoring that after it's migrated, everyone is capable of doing their work. So it's a very important phase when you have an innovation to capture that end to end. And another term for that is mobilizing the change. So making sure that any solution that's being done is successfully mobilized to offset potential areas of failure. So now with quality characteristics, what do we mean specifically when we refer to quality? And the reason that I'm elaborating on this is that by understanding what the characteristics are, that identifies specific areas of failure and in turn countermeasures that would have to be applied. And two very good references for this are in the ISO standards 25010 of software quality and 25012 data quality. So quality 4.0 incorporates solutions that possess these quality characteristics, which is why I'm sharing this. There are 4 models, 2 from software and 2 from data. The quality and use model represents software as a service and how it would be applied or deployed. And then the product quality would be the quality characteristics of the technical solution itself. The inherent data quality represents what is the data like in its own way, and then when the data is put into a system or an application or infrastructure, the system dependencies are how those elements affect the data. So I can elaborate very quickly. Quality and use is the business needs. Why are they using the software? And some of the characteristics that they aspire to have are shown: effectiveness, efficiency, but also freedom from risks, and making sure that the software covers the necessary context. And I won't elaborate on that so much, but really from a perspective of cost of quality, we're managing risks and we're managing potential failure costs. So if the software is not suitable, it won't be used. So then if it's not used, then that deployment is delayed. If it's excessively complex, so coming back to the enterprise resource system, if someone, let's say purchasing agent, who used to just get a post-it note and would make a phone call to the supplier saying, yeah, we need 100 more units, that's the manual approach. If using the software is more complex, they will simply disregard it and continue using their old manual method. So, which then negates the effectiveness of the solution. And then ultimately the failure to manage expectations. This is where it's important to have that analysis phase of why is this being applied? Is it being done to improve end-to-end delivery time? Is it being improved to permit more innovation? And if those expectations are not met, then you've lost the investment. So the failure costs of this: incomplete transactions, costly malfunctions, which if you do get problem with the design, or the two systems that were intended to talk to each other, they prove to be incompatible, then the malfunction has to increase an additional step. And ultimately the damaged customer relationship, if the result of quality 4.0 actually blocks you from delivering, and it was done more quickly when it was done manually, that's a major setback. So in terms of the software itself, I won't go through all of them, but this is what the ISO standard has as examples of ways that quality is represented. And from a cost to quality perspective, these represent areas that could either fail or would have to be where failure needs to be appraised and ultimately prevented. Failure, ultimately, reliability and security are very tangible examples where a solution could fail. For example, if you've got upgrade in the database, but as a result of that upgrade, you lose your confidentiality, or if the data changes that you're not sure if it's truly accurate, then you lose that. Those are failures that have to be mitigated. In terms of usability, the expectation is that if someone receives a solution, it should be able to be immediately deployed. So one of the measures is ease of users to access and learn. if they have trouble downloading the software or downloading the solution onto, for example, one quality 4.0 is increase of mobile applications, and that touches on both usability and portability. If a user base has a particular brand of devices that the system is not compatible with, then it's both not portable, they can't install it, they can't get the same benefits, and then if they can't access, they can't learn and operate it. So also touches on compatibility as well. So it's these prompt some very key areas of potential failure, which should be tested and planned. And then the risks of if the software is not okay. I've let's see. These prompt the areas of tested and planned. The business risks of this is that, oh, I've actually moved ahead, sorry. So costly problems and complexities, and again, if the software is not suitable, if the quality 4-point solution is not suitable, to be bypassed, and then magnified and cascade into other systems or functions. So coming back to the aircraft failure, a small software, it wasn't a small failure, but it was confined to a particular feature, a sensor. That sensor error affected the ability of the entire aircraft to fly correctly. So that's an example where it's cascaded. In another case, it's very important when we're doing healthcare. A small isolated error in terms of a diagnostic system could give the wrong reading, which would then give the incorrect treatment mode. So that's where having these failure costs can be amplified well beyond the cost of the software itself. The data quality, if the data itself is, there's criteria for the data that has to be accurate, complete, ultimately credible, and that if you're using it, the business risks is that you use the data to make a decision. For example, what business response do you make? Do you purchase more material? Do you increase advertising? Do you hire people? Do you, or if it's, let's say weather is something, is a storm coming? Is there flooding? Is there a high level of precipitation? Based on that, might affect if people have to evacuate or if they have to take measures based on that data. So then if the data is not itself is flawed, then there's lack of confidence, and it can either make incorrect decisions or it'll be disregarded and the timely response will be delayed. Also, if it's known to be flawed, then there's a corrective element of having to restore that data, restore the applications that produce and hold that data as well. So it could be a signal of flawed systems or flawed applications, which also have to be corrected. Now, as far as those systems that manage, there's looking at all the things, and again, I won't go through this, but some examples are, is it traceable? Can someone looking at the data know with confidence where it comes? And then, trusted sources. Also confidentiality, which is, ties back to security. Is this data, is it available for someone who needs it, but restricted from someone who should not have it? Or if it's someone is looking at it, can it be, corrected so that it prevents, it's mitigated? And that the implications of having these problems are usability and integrity. So if the data is lost or corrupted, then again, it's nullified. If it's lost because of a flaw in the software or infrastructure, then won't be used, and those business impacts of not having timely decisions are made. Alternatively, if it's a security breach, then there has to be a recovery of business continuity, recovering the relationship, and then addressing how to recapture that lost data. So as you can see, the potential for failure expands exponentially with more quality characteristics to be managed. So then what does this mean for managing the costs? By identifying the quality characteristics and the potential for risk and failure and tracing those to business impacts, that helps to prioritize, what could go wrong, and use that as a basis for what safeguards have to be put in place, with the safeguards being preventative modes and appraisal modes to identify that proper levels are being tracked. So, and Quality 4.0, whether it's your enterprise-wide system, whether it's additive marketing, deploying things to different devices, or infrastructure from what are called on-premise devices to in the cloud where it's a shared system, any of those have their own inherent risks and potential failures. So they should be risk-based estimates, and from the potential for occurrence, determine through a cost to quality model what appropriate investments are to prevent and appraise them. And by having a broad scope of countermeasures, rather than doing it one by one, this is a good chance to revisit this and operate it in a systematic way, whether you have it as a management system or as a series of lean programs. It comes in, the countermeasures can start at the planning and project management, so with the stakeholders, going back to the phases of business analysis and then change controls, verifying that the traceability between requirements and quality characteristics, and validating the intended environments. Just between those two, that robust appraisal will highlight shortcomings, and in turn might even cause back to a redesign of, is this too complex of a solution, or are the risks within our capability to manage? So, and then mitigation and contingency planning. Contingency planning, what's the safeguard if this failure is inevitable, then what's our next step? So for example, if it's inevitable that someone will hack the data, one contingency could be that the data itself is removed after a 4-hour period, and the entire password is changed again, so that if someone gets in, they have a time limited access. It's not left. There are, and it takes a number of solutions, but because, to come back to it, quality failure costs, because of the complexity and the prevalence of software and information technology and Quality 4.0, there will be a breadth and impact and criticality of potential quality failure costs. So the way to offset that is use the proven methods for software and information technology, not just the sequence of it, but looking at the quality characteristics of those solutions relative to software, data, and data management, and make that part of the planning for cost evaluation and risk management. By addressing this proactively, instead of waiting for the failure to occur, those internal and external failures can be prevented, or were unable to be prevented, have compensating contingency plans to offset the impacts of those. It's and by doing that, because the costs of appraisal and prevention are more known, they're more planned, then more effort can be devoted to, because those issues are largely controlled, then it's a better opportunity to get the return on investment and realize the benefits of your Quality 4.0 innovation. So, and at this point, as questions come in, I can circulate back and forth on the presentation. So, are there any questions to start with?
Dan, thanks for that. Really do appreciate your presentation on Quality 4.0 and some of the cost associated with it. A couple of things before we do take questions, which, by the way, I only have a couple right now. So feel free to get your questions in. In the meantime, in the questions section, I put in Dan's contact information, both his email as well as his profile on LinkedIn. So if you're looking for this copy of the slide deck, feel free to reach out to Dan directly. Again, in the handouts section of the control panel for GoToWebinar, you'll see one handout. It happens to be the registration link for next month's presentation on the Internet of Things. And I think after that, I've got, just like I said, a couple questions so far. So feel free to get them in. So Dan, your first question. As an end user of software for either quality or process control, how can parts of the ISO 25K be implemented as part of our QMS in order to get the desired performance?
Thank you. I think that if I understand the question correctly, how can elements of ISO 25010 be applied? I've reverted back to slide 22, which shows some of the categories. So I think first of all, it's very important to acquire a version of this, which details some of these out, and incorporate that into your verification validation plan. So in terms of the software itself, whether you are developing it or getting it from a third party, having clear requirements of what you need is important to understand. What does quality mean? So use this to define your acceptance criteria, and then once you have your acceptance criteria, evaluate the software performance relative to that. So what do these items mean for your business specifically? And where they come up short, then whether it's, if you develop that internally, then you can report it as a defect or an incident. If it's third-party software, you can contact their technical support and determine a resolution plan if it's part of their product roadmap. Quite often these companies, these are already known issues, and they'll say it's 2020, we've got a version in March 2021 that'll address these known issues.
Okay, great. Another question that we have so far: have you used FMEA for IT service creation and maintenance? If so, what are your thoughts regarding the pros and cons of this approach?
Failure mode effect analysis is a very good structure in medical devices, failure mode effect criticality analysis. And I think it is very good to identify the technical failures, and then the effect is good to have it replicated as the business impact. So if, for example, if the database fails, what does this mean for your business? And they say, well, we can't take customer information reservations, which then inhibits the customer transactions. Specifically on that, the calculation of the risk priority number is flawed because these use ordinal scales from, say, 1 to 5 or 1 to 9, and it's not good mathematical practice to multiply ordinal numbers to get a risk priority number. So that said, it's still a good way to, you do that to prioritize your failures based on severity, criticality, and ability to detect, and that is helpful to prioritize which potential technical problems to resolve first.
Okay, good. Couple more questions that have come in. So one is, do you think that the speed to develop software applied into an agile framework when planning, prevent, and testing is affecting the vulnerability and quality? Do you think the need to develop software applied into an agile framework when planning, preventing, and testing is affecting the vulnerability and quality?
Yes, it affects it, but it's it could be both something that detracts from quality and enhances quality. In Agile, you have what's called a backlog, and the backlog is a summary of what you want to accomplish within each increment. So the portion of that backlog which is devoted to testing or appraisal or preventive activities will determine how robust the increment is. So if you've got 10 items on your to-do list and one of those 10 is just test, then at the end of it, you might not have you might have a thinly tested solution, and then building upon a series of thinly tested solutions that might be inadequate for quality. In contrast, if within the Agile, say if your to-do list of 10 items, you have 4 or 5 which are more specific and dive more deeply into how the solution is verified and validated, you have a better chance of coming out of that with something that's assured and demonstrated to work, and you can build on that to show how those acceptance criteria are fulfilled.
Okay, I think we have time for one more question, and that is, what is the current leading platform for software? Python was very popular, but it seems like there are many new systems today.
I agree that I've inadvertently shut the thing. Let me reopen the slides. So Python is very good. I think a question like that, I'm not the right person to respond. I can only say that in my experience, Python is something that's widely used and increasingly used for database and data-driven applications and solutions.
Okay, all right, great. Well, I see it's just after 2 o'clock. Dan, once again, I would like to thank you for talking on the subject of cost of quality for Quality 4.0. It's a hot topic these days, obviously, and managing cost of quality always is. Folks, again, in the handout section, or keep your eyes peeled, you'll see a registration link for next month's webinar with Mo Abwali on the Internet of Things and basically how to interconnect the equipment in your area to have it talk to you so that you can get better information. Dan, thank you again. Any final words?
I appreciate this. One of the things I really tried to do is make the connection between this material and what a lean enterprise practitioner would find. And I really hope that my takeaway was to identify areas of waste and defects within Quality 4.0 innovations and initiatives.
Okay, great. Once again, thanks, folks. If you are looking for the presentation, again, I would remind you to look Dan up on LinkedIn or hit him directly. I did post his email address in the questions. Otherwise, I thank you for your time and your attention and your questions, and hope you enjoy the rest of your day. Dan, same to you.
Thank you.
Take care now, folks. Bye now.